Hello everyone. Today we'll talk about visual cryptography in online transactions. So let's begin. What is cryptography? Cryptography is the technique of keeping information safe and secret. It involves turning messages or data into a code so that only those who are supposed to see it can understand it. This process of turning messages into a code is called encryption, while its undoing is known as decryption. Now let's start by what exactly plaintext and ciphertext are. To put it simply, plaintext is like a message written in a language that anyone can understand, while ciphertext is like a secret code that only those who know how to decipher it can understand. Encrypting plain text into ciphertext is an important technique used in information security to protect sensitive information from unauthorized access. So now let's understand what is a symmetric key. A symmetric key is a key to a lock. Just like how a key can unlock a door and lock it back, a symmetric key can encrypt a message and decrypt it back. However, in the case of symmetric encryption, the same key is used for both processes. So this is an overview of online transactions. So let's first understand what is an online transaction. An online transaction is a type of electronic transaction that occurs over the internet. It involves exchanging of information and or money between a buyer and a seller or service provider through a website, application or other online platforms. Online transaction can include a wide range of activities such as e-commerce transactions, online booking transactions, digital currency transactions, and online bill payments. So now let's move towards introduction of visual cryptography. Visual cryptography is a cryptography technique that uses visual elements to make to process of encryption and decryption more secure. Now let's take a deep dive. What is visual cryptography? Visual cryptography works by sharing a secret message by turning it into multiple images that look like random patterns. These images are given to different people and the secret message can only be revealed if they combine the images in the right way. This is done by encoding each bit of message into multiple pixels of different images. When you put the images together, the message becomes visible, but if you only look at one image, it won't make any sense. Visual cryptography can be used to keep information safe in different areas like making sure someone is who they say they are, adding a watermark to a digital image or sending images securely. Now let's see what idea should you have. So what everyone should know about visual cryptography is this. It starts with taking a carrier image in which a secret file is embedded to make the final carrier image which is transmitted. Now you must be wondering how this secret file is formed in the first place. So the secret message is converted to a binary string which is the secret file. After being transmitted, the decryption process takes place on the receiver end to separate out the secret file from the carrier image. So this is how basic visual encryption and decryption works. Moving on. Now let's say what's this? So let me define some terms. So let the secret white secret pixel denote that we are going to do an AND operation, and black secret pixel denote that we are going to do an OR operation, bitwise OR and bitwise AND operations. So let's say our target image is as shown here in the first part. So if let's visualize our target image as some binary string. So if we want exact this string, we can divide the string into two strings which are exactly identical to it. If we are gonna do a white secret pixel secret pixel operation, which is an AND operation. So let's say our share 1 is a string 1 and share 2 is string 2. So if we gonna do a bitwise AND operation between them, we'll get the target image as shown. Similarly, if we have black target images as shown here, two black cubes, squares, so this can be divided into two different strings where we have as shown by share 1 and share 2, and white secret pixel here means we are gonna do bitwise OR operation. So on doing bitwise OR of share 1 and share 2, and also taking into consideration that white denotes 0 and black denotes 1, we'll get this target image as whole black as shown here. Now moving on. So how do we exactly visualize visual cryptography? So as we talked, let's say our secret message is MAJWKDNK. We encode it with some algo and convert it into a binary string as shown here. Now this binary string is further converted into a QR code with the help of visual cryptography, and then this QR code is cut in different four parts and shared with different four people, and distributing these QR codes with different four peoples do not have any meaning individually, but when they combine the QR code in a right way, the whole QR code is together, and we can decrypt back our original text, which was MAJWKDNK, by just combining the QR code in a right manner. So these are the results of our implementation. Let's say we have a secret file, we share it, we convert it into two different images, let's say shadow image 1 and shadow image 2. These are some random dots and they do not have meaning individually, but if we stack them together and combine, we can read the secret image or secret file that was meant to be shared. Now let's move on to the applications of visual cryptography in online transactions. So yes, these are the different images which are used in visual cryptography. First are random dots. This technique uses a set of randomly generated black and white dots to encode information. When the two images are overlaid, the original image is revealed. Then comes the QR codes. These are 2D barcodes that encode information such as URLs, text, or other data. They can read using a smartphone, QR code reader, etc. QR codes can be used as a form of visual cryptography by splitting the information into two or more QR codes and distributing them separately. The original information can only be decoded when the QR codes are combined correctly. And the third are the colored squares. This is a technique where an image is divided into a grid of colored squares. Each square contains either black or white pixels to encode the secret images. When the colored squares are overlaid, the original image is revealed, as we saw in that example of white secret message and black secret message. Now let's look at some applications of the visual cryptography. So where we can implement this method. This method of visual cryptography can be implemented at various places such as secure authentication, password protection, and transaction confirmation. Okay, so let's look at the existing system of buying something. So let's say you log in into a system. So here we'll take example of Amazon. You visit it, add some items to your cart, and just check out for payment, and you give everything the Amazon site asks, let's say password and CVV to it. But here is a drawback in method. The password and CVV can be misused by Amazon, and so the drawback is we must have faith in Amazon that it will not do anything wrong with the card holder and its account. So this is a drawback which can be removed by visual cryptography. Let's see how. So if we implement visual cryptography in this system we discussed, let's say there are three actors in this case. First actor is the person who wants to buy something. The second actor is Amazon website from where he or she wants to buy, and the third actor is bank, let's say SBI bank. So what happens now if you add some items to your cart and you want to check out for buying them, and whenever the prompt of giving password and CVV of your credit card details comes, you can you can use visual cryptography in which two different images, they are also called shares. So two different shares are created. First share will be kept with the user itself, and second share will be given to the Amazon website. So when asked by the bank, when the request is sent to the bank will ask for the first share from the website itself and second share from the user itself, and it will superimpose those to decrypt the message. And if the proper image is formed, the bank will validate funds and validate funds and transfer the money to the Amazon website, and hence user will get his or her desired product which he kept in his cart. So this is basically how a visual cryptography system works. Now let's look at some advantages of visual cryptography. Visual cryptography is a simple and easy to implement cryptographic technique that does not require complex algorithm or keys. It does not require any computational resources, making it ideal for use in low resource environments. Furthermore, visual cryptography does not require the use of a secret key, which eliminates the risk of key exposure or loss. Visual cryptography does not require any mathematical expertise also, making it accessible to a wide range of users. Lastly, it is robust against brute force attacks and other forms of cryptographic attacks. Now let's move on to the disadvantages on the next slide. So here are some disadvantages. Visual cryptography requires multiple shares, hence increasing the storage and transmission requirements. The size of the secret messages that can be encrypted using visual cryptography is limited by the number of shares used. Visual cryptography is vulnerable to attacks that can reveal the secret message if an attacker has access to a sufficient number of shares. Visual cryptography is also limited to applications that require the sharing of visual information, such as images or text. Lastly, it provides a low level of security compared to other cryptographic techniques such as public key cryptography or symmetric key cryptography. Here are some limitations of the visual cryptography. First, visual cryptography has a limited information storage capacity compared to other encryption methods. This is because visual cryptography relies on the distribution of shares, and the more shares required to reconstruct the original image, the larger the file size becomes. This can make it challenging to use visual cryptography to encrypt large amount of data. Second limitation is that it is not very scalable, meaning that it may not be practical for large-scale applications. For example, distributing shares to a large number of users can become very complex and time-consuming, making it difficult to implement on a larger scale. Third and lastly, it is vulnerable to attacks. Visual cryptography is vulnerable to certain types of attacks. For example, an attacker may try to modify or distort one or more of the shares in order to alter the final image or information. Additionally, an attacker may try to intercept or steal one or more shares, which would compromise the security of the original information. Now, moving on, let's just discuss the future of visual cryptography in online transactions. So here firstly we can integrate the visual cryptography system with biometrics. To integrate biometric authentication with visual cryptography, one approach could be to use biometric data as a key to unlock the shares and reconstruct the original image. For example, a person's fingerprint could be used to generate a key that would be required to combine the shares and reveal the image. This would add an extra layer of security to the visual cryptography technique, as an unauthorized person would not only need access to the shares but also the biometric data of the authorized individual in order to reconstruct the image. Secondly, we can also integrate it with AI. One way to integrate it with an artificial intelligence is to use machine learning algorithms to generate the encryption keys. These algorithms can learn from large amount of data to create more complex and secure encryption keys, making it more difficult for unauthorized parties to decrypt the image. Thus, this will increase overall level of encryption and hence increasing the security. So here are our team members. Thank you.